And the next presentation continues the subject of catalytic reaction. It is by Brendon Disrud, and I would like to bring to attention that this course was offered to both graduate and undergraduate level students to bring the same level of technical skills and cover broader audience. Floor is yours for generous 4 minutes.
All right, I'm Brendon. I was looking at reaction between carbon nanotubes and hydrogen peroxide. A little bit first on all the different types of carbon nanotubes. They're split up into single-walled and multi-walled, but we're going to be using only single-walled and only one specifically because single-walled are much smaller. And then there's also a specific vector that is applied to the carbon nanotubes, which describes their shape. The single wall versus multi-wall. Single wall is probably your basic one atom thick, and multi-wall is pretty much like a single wall inside of another single wall, and so on. For the vectors that describe them, you can think of them as a graphene sheet, and then vectors along that graphene sheet point to another carbon that you would roll up into a tube and connect them there. So the three types that we could get when we do this are zigzag, where one of the pairs of vectors is a 0. So I've tried to highlight them in these pictures here so you can kind of get your mind around them. And we're going to be using zigzag, but there's also chiral vectors, where it's 2 unique numbers, and armchair, where both of the pair of vectors are the same. So we use the 4-0 that you saw earlier on the zigzag one, and we expected when we react it with the carbon nanotube, or the peroxide, that we'd get some formation of epoxides and carbonyls, as well as a burning reaction where carbon is removed from the carbon nanotube to make CO2 gas or something of the like. And this would make a hole on the nanotube. So we looked at this unit cell here, which is 2 units of the carbon nanotube long, and it has 16 hydrogen peroxides around it. And we ran a dynamic simulation for that. And one interesting part here, you can see the reaction between the hydrogen peroxide, one of the pathways here. The hydrogen peroxide breaks and a hydroxyl group goes and forms with the nanotube, which is one of them that I did not expect to happen. And in this still frame here, it's kind of hard to see, but the 6-member ring on the carbon nanotube was functionalized with 3 different oxygens, and it actually broke and created a hole on the nanotube without dissociating a carbon off of the nanotube. I also looked at the system under both cationic and anionic states. The anion is here, and we see more reaction, but nothing like the cationic state where the whole nanotube kind of just breaks apart. And the ionic states we looked at are probably more than you might expect to find in a regular lab experiment, but it will give a good approximation of what we can do with a more limited time. So what we did see was reactions that I didn't expect. First off was the hole with no leaving group. We saw an epoxide form, and it was stable for hundreds of femtoseconds, but ultimately it did go to form a carbonyl. We kind of saw maybe a little bit of the burning with the cationic state, but not really anything like I had expected. And then hydroxylation and hyperoxide formation that I didn't originally expect, but we saw those as well. All right.
Okay, let's thank Brendon for a very interesting presentation.